Suppose that one pump can empty a pool in 24 hours, and a second pump can empty the pool in 30 hours. A, write an equation whose solution gives the time needed for the pumps working together to empty the pool. And part B, solve the equation in part A. It's always good to set up a table when you have two particular, in this case, pumps working together. We know that rate times time equals work. So the first pump has a rate of one pool in 24 hours. The second pump, one pool in 30 hours. We're going to let x equal the time that they take working together to empty one pool, so they each work a total of x amount of time. In this case, we would say hours. So what is the work that pump 1 does? Well, it's x times 1/24th, or in other words, x over 24. The amount of work that the second pump does, x times 1/30th, which gives us x over 30. Now together, the amount of work that pump 1 does plus the amount of work that pump 2 does must equal 1, which is the one pool that they will empty working together. We want to multiply both sides by the LCD. In this case, the LCD of 24 and 30 is 120. So we would multiply 120 times x over 24 plus x over 30, and we would multiply 1 times 120. Now on the left-hand side, we need to distribute the 120. When we do so, 24 will divide into 120 5 times, so we would have 5x. Plus, when we multiply 120 times x over 30, 30 goes into 120 4 times, so we have 4x. And 1 times 120 is 120. So we have 9x equals 120. And that means x is 120 divided by 9. Right away, you can see that we can divide both of those by 3, giving us 40/3. And if you change that to a decimal, it's approximately equal to 13.3, and that is hours, since that's the time frame we were given for the rate at which these pumps work. So our answer is it would take approximately 13.3 hours for both pumps working together to empty the pool.